Okay. Hello, my learners. Let's get to lesson 15. Right. So, lesson 15, we will be talking about, in fact, I will explaining concepts which will be pivotal when sketching cubic functions. Right. So now let's go back a bit. Remember in grade 11, right? You were taught that the formula to find the the x coordinate of the turning point is given by that, right? And we lied to you and never told you actually why are you doing that, right? Because at that time you were not introduced to calculus. But because you're introduced to calculus now, I have to say to you, or I have to tell you actually why you using this formula. Right, but before that, let's sketch our parabola. Suppose I've got a parabola here. I will limit this f of x, which is x squared minus 4x plus 3, right? So let's sketch our parabolic function. So the y-intercept, when x is 0, and you can see that actually we just get 3, and then 3, 0, and 3 are actually our y-intercepts. Sorry, it's our y-intercept. And then for x-intercept, x squared, okay, we know that for x-intercept, y is 0, or y results to 0, and then x squared minus 4x plus 3 is 0, and then x minus 3, x minus 1 is 0, x is 3, or x is 1, right? We know that. And then now we know, okay, let's find the coordinates of the turning point. So let's just say turning point here, right? In fact, my YouTube channel name was born out of this. So TP, turning point Villagas, right? So let's continue. Right, we said xp is minus that, and then it's negative 4 over 2 times 1, and that is 2, right? And then the y value, ytp, we take this, substitute into the original function, plus 3, and then you'll get minus 1. Yes, therefore, coordinates of the turning point are actually 2 and minus 1, right? Okay, now let's sketch our beautiful quadratic function, right? Okay, right, let's have a beautiful diagram there. Okay, right. So there is something that we are going to discover yourself here. Right, so, so our function will be like that, and it will be like that. So that is going to be 3, that is 1, that is 3, that is 2, and this is negative 1. Hence, we have 2 there and minus 1, right? Okay, now there is something I want us to discover here, right? We said when you are looking for the x-coordinate of the turning point, we use this guy in grade 11. We lied to you guys, and we are sorry about that. Now let us tell. No, actually, we didn't lie to you. We did not tell you as to why you are using that, right? So I'm here to tell you why that is the case. So, okay, let's write our function. So f of x is x squared minus 4x plus 3, right? Good. Now let's find the derivative function. So the derivative function is 2x minus 4. Remember, we are going to use this guy to actually determine the gradient of the tangent at any point on the graph, right? So let's do this, right? Number 1, let's determine the gradient of the tangent when x is 0. Let's look at the coordinates here at this point, right? At this point, we've got 0 and 3, right? So let's find the gradient at that point. Okay, let me call it point A, and then I'll call this one point B, and then I'll call this one point P, And then I'll call this one point T. Right. So let's find the gradient at A. So MT, right. So let's just do this. Let me just say at A, right? So MT is F at, what is the X value at A? It's 0, right? So 0 is going to be 2 times 0 minus 4, which is negative 4. Right. It means now at A, the graph is decreasing, right? The graph is decreasing. The gradient of the tangent is negative there. Now, let's look at the gradient at B, right? The gradient of the tangent at B, or the gradient of the function at B. So f prime is 1 there. So it's 2 times 1 minus 4, which is minus 2. Now, discover something here. Can you see that from negative infinity up to just before P, the graph is decreasing here? Can you see that? In fact, I think for that, I should use a different color. Now, let me remove that. Let me use a different color for this one, right? You can see that the graph is decreasing. It's negative. Okay, let me fix my font there. Right, okay. Yep. Right, so you can see that the graph is decreasing here. All right, that's too small. Much better. Right, so the graph is decreasing here. Why? Because in this region, the gradient is actually negative, right? Right, the gradient is negative. So actually, let me draw the green line here. Right, so remember the x coordinate of the turning point is actually the symmetrical axis of this parabola. Right, okay, so you can see that this side of the graph is decreasing. All right. So now let's look at the gradient of the tangent at point T now, right? So at point T, MT is F at 3. Remember at point T, the x value there is 3. Then that is going to be 2 times 3 minus 4, which is positive 2. Right. Now, at point T, the graph is increasing. Now, let's have another function, another point here, which we are going to call V, which has got an x coordinate of 4. Well, we don't care about the y coordinate. We don't need the y coordinate. We're just interested on the x coordinate. Right? Let's find the gradient there. The gradient at V, so MT at V, is f prime at 4, that is 2 times 4 minus 4, which is 4. Right, now something is actually happening there. Now, can you see that just after point P, remember point P is the turning point, right? The gradient is now increasing, right? So the derivative in this region is actually positive. Can you see that? So, right, so that means from negative infinity to just before P, the graph is decreasing. Just after P, the graph is increasing. Interestingly, now let us look at the gradient of the tangent exactly at P. Remember, P is the turning point, right? I'm going to write that. Gradient of tangent at P, in bracket, I must emphasize, is the turning point. Let's look at that. Now, MT is F prime. Now, what is actually the x value at P is 2, right? 2, right, sharp. Then that's going to be 2 times 2 minus 4, which is 0. Wow, beautiful, absolutely. Now, remember, if we were to draw the tangent here, the tangent will just be straight here. The tangent will just be straight. So now we just discovered something beautiful here. At the turning point, the derivative is 0. So the gradient of the tangent at the turning point is 0. Can you see that? Right? So we know that at P now, which is the turning point, the gradient is 0. So from negative infinity to just before P, the graph is decreasing. At P, the graph is 0. It's neither increasing nor decreasing. It's just stationary. So the gradient is 0. Then after P, just after P going to positive infinity, the graph is increasing. So now, where am I going with this? Let me show you. Look at this. Remember, we said to you, okay, rather use green instead of blue. Right. Remember, we said to you, f of x is ax squared plus bx plus c, right? Now let's differentiate this. So when you differentiate this, we've got 2xa plus b, right? But now I said to you, at the turning point, the derivative is 0. So at turning point, the derivative is 0, right? So now let's take the derivative equal to 0 and solve for x and see what we get. So this is 2ax plus b, which is 0. Now I'm going to transpose the b to the right. Then it becomes negative b. Then I'm going to divide everybody by 2a. And that's what we get. Voila! Exactly. Can you see that? So now this is how this formula was constructed. Can you see? We just went back to this. Can you see that? So now in grade 11, we didn't tell you why that is the case, but now in grade 12, we are proving to you as to why this is the case. So I was showing you this so that you know where it comes from, and we are going to use this to actually calculate cubic functions, right? So this is what this is all about. So at a turning point, the gradient of the tangent is 0, right? So now let's actually go back to cubic functions now, right? Let's go back to cubic functions a bit. So let's actually diagnose this, right? So I'm going to partition the graph into 3 parts, right? So I'll have the first part there and the second part there. I will have region 1, region 2, and region 3. I will do the same thing here, right? Okay, okay, it's fine. I'll just start afresh. I've got region 1 there, region 2 there, region 2, region 3. And then I also have another thing, another partition there, region 1, region 2, and region 3. So let's discuss this, right? So look at this. In region 1, the graph is increasing, right? The derivative there is positive. Positive. Can you see that? Then at the turning point, we know the derivative is 0. Even here, the turning point, the derivative is 0. Now in region 3, still the graph is actually increasing, right? But now region 2 now, the graph is actually decreasing. So the derivative there is actually negative, right? Now let's look at the case whereby a is negative, right? Region 1, the graph is decreasing, 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 and then it's 0 at the stationary point, the 0 at that stationary point. Region 3 is also decreasing, 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 decreasing. Then region 2 now is actually increasing, positive, 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 positive. Can you see that? So once you understand this, and then you'll be fine. So let me pause here for now, and then the next lesson we are going to actually draw cubic functions, and I'm going to teach you synthetic division because we need that to actually find the x intercepts of the graph.